Hello and welcome to Nursing School Explained. Today we'll go over homeostasis in the body and the regulation of pH that really helps us to regulate all our body systems. We will look into acidosis versus alkalosis. We'll go over the different steps on how to analyze arterial blood gases, and then we'll go into different examples on how to really apply this. So first, let's look at the pH. A normal pH level is 7.35 to 7.45. So this is a very narrow normal range, and it really helps our body to maintain proper functioning, and it's really a state of homeostasis. If the pH goes below 7.35, then it's considered an acidotic state. If it goes above 7.45, then it's considered basic or an alkaline state. So these are the very basics that you hopefully remember from physiology class. So now let's see how that applies to our body system. So I've drawn out here an equation that you may remember from chemistry. So we have H2CO3, which is carbonic acid. And carbonic acid is a byproduct of cellular metabolism that can be broken down in several different ways. First of all, it can be broken down by the respiratory system by breaking H2CO3 up into H2O and CO2. So the respiratory system will break down the carbonic acid into water and carbon dioxide. As we know, the respiratory system is in charge of gas exchange, so it'll be in charge of oxygen and carbon dioxide exchange at the alveoli, and we'll go over it in a moment here as to how it does that. Now, on the metabolic side, on the renal side here, this carbonic acid can be broken down into hydrogen ion and bicarbonate, so H plus and HCO3 minus. Again, we have two H's and then CO3 right here. So this can be broken down. And the kidney will filter the hydrogen ion and the bicarbonate by either increasing or decreasing their reabsorption to balance out the pH. So now, as you can see, I have color coded here. So everything in red is acid and everything in green represents alkalosis over here. And these two systems work together to balance the pH. So typically when there's something going on with the respiratory system, so let's say the patient has a bad pneumonia, a pulmonary embolism, atelectasis, narcotic overdose, which decreases respiratory rate, there is a need to balance the pH because the respiratory system has now been compromised. And so when there's something going on that's based on the respiratory system, a disease, then the metabolic, the renal system will kick in to try and balance whatever is going on with the abnormalities of the respiratory system. And it works exactly the same vice versa. So the renal system, if there is something going on with the renal system where now, or with the metabolic system, where now the pH has got out of balance because let's say the patient is septic, they have a very bad infection, they've had major burns, they have renal failure, they have there can be all kinds of underlying issues that I'll be discussing in a separate video that can be the cause for metabolic imbalances. So where the renal system somehow has taken an impact and now there's either too much acid or too much base in the system, and then the respiratory system will try and compensate by regulating this by increasing or decreasing the respiratory rate to increase or decrease CO2 absorption depending on what's needed at the time. So in an acidotic state, when the pH is less than 7.35, the body is going to try to increase the pH level. And the way we do this, if there's an acidotic state, the respiratory system will increase CO2 excretion by increasing the respiratory rate. So when we increase CO2 excretion, we get rid of some of those acids and then therefore from an acidotic state we'll go back to hopefully a more normal pH state by increasing the pH level. Now on the renal or metabolic side, the kidneys, if there is an acidotic state with a pH of less than 7.35, the kidneys will compensate and they will increase our bicarbonate absorption, because now we have too many acids, which really represents the hydrogen ion here in our system. We will increase the absorption of that bicarbonate to balance out the acidotic state, and again hopefully bring it back here into the normal state. Now in an alkaline state, the pH is greater than 7.45, so what we really need to do is decrease the pH to bring it back into the normal range. So what the respiratory system does, it decreases CO2 excretion by decreasing the respiratory rate. And therefore, from an alkaline state, we now reabsorb, we now have more CO2 in our system, which we know here is more acid. So now we go from an alkaline state back towards the normal pH level. Now, when we look at it from the renal or metabolic side, in an alkaline state, which is right here, basic, our bicarbonate, there is too much of the bicarbonate in the system, so now we need to get more towards the acidic side. So the renal system will decrease the bicarbonate absorption and therefore increase the hydrogen absorption, therefore balancing out this basic to the normal pH state. This really applies to ABG, arterial blood gas interpretation. And the first thing that we need to do is to look at the normal values. I've written these in a box in red over here, and I've written big memorize. So we all know that nursing school is all about application and analysis, but there's still certain things that we need to memorize in order to be able to apply the material. So this box is one of those things that you will just have to memorize. First of all, pH, normal value, 7.35 to 7.45, as we've just discussed over here. If it's lower than 7.35, it's an acidotic state. If it's higher, it's an alkaline state. PCO2, I just like to remember it's the same numbers, but without the 7 as the pH. So it's 35 to 45, but it goes the opposite way. So if it's increased, if it's higher than 45, it's acidotic. If it's lower, it's alkaline. Bicarbonate, normal values are 22 through 26. If it's lower, it's acidotic, and if it's increased, it's alkaline. So the pH and bicarbonate move in the same direction as to if it's higher or lower, if it's acid or alkaline, and the pH really moves the opposite. Again, just memorize these. Also refer back to your professors and your textbook, because values may differ by hospital, by your textbook, by your professor, but in general, these will be pretty much the same everywhere. So I've written out some steps here on how to go about interpreting these ABGs. So first of all, we're going to look at the pH. We're going to look at the pH and determine if it's normal, acidotic, or alkaline. Number two, we're going to look both at the PCO2 and the bicarbonate to see which one of them matches the acidotic or alkaline state of the pH. Step number three, we're going to look at the opposite system. So if we've now determined that, let's say, the PCO2 matches the pH, then we're going to now look at the bicarbonate. So that's the opposite system that's trying to compensate to try and bring the pH back into normal range. So there are three different things that can happen here. The opposite system, or the EBG, can be uncompensated. In that case, we would have an abnormal pH, and the opposite system has not responded, meaning that it'll be in normal range. For partial compensation, the pH will still be abnormal, but both bicarbonate and PCO2 will be abnormal, meaning that now we have an abnormal pH that's somewhere out of range, but they're both trying, so one of them is acidotic, one of them is alkaline, and they're both trying to bring the pH back into normal. If it's fully compensated, that means that the compensatory system, whether it's renal or respiratory, has kicked in and the pH is now normal, but both the bicarb and the CO2 will still be abnormal, meaning that now the pH is normalized, but one of them will be over here, the other one will be over here, but together, they work together to bring the pH back into our normal range. So let's look into some examples to really apply this information. I highly recommend memorizing these numbers and then also memorizing these steps, because then you have no problem analyzing ABGs. So first example over here, our pH 7.29 means that it's acidotic. PCO2 54 is acidotic as well. Bicarbonate is 30, which means that it's alkaline. So first thing, we label our pH, we say it's acidotic, and then we see which one of the two, bicarbonate or PCO2, matches it. So in this case, the PCO2 is acidic, so we know that the primary offender here is a respiratory acidosis. These two match, acidosis, and PCO2 represents the respiratory system. Now we need to look at our compensation. So step number 3. The pH is abnormal, and both of these are abnormal, right? We have one acid and one alkaline. So we have an abnormal pH with both bicarbonate and PCO2 being abnormal. So in this case, we have a partially compensated respiratory acidosis. Let's look at example number 2. pH 7.49, which is alkaline. PCO2 is 30, which is alkaline as well. And then our bicarbonate is 24, which is actually normal. So now looking at the pH again, it's alkaline. What matches is the PCO2, so we know that we have a respiratory alkalosis. And now the bicarbonate is normal, so the opposite system has not responded. So there's basically, the renal system has done nothing to help us increase this or decrease this pH. Therefore, it is an uncompensated respiratory alkalosis. Example number 3. pH 7.25 means acidotic. PCO2 is 30, meaning alkaline. Bicarbonate is 17, meaning acidotic. Again, I determined my pH is acidic, so is my bicarbonate, so I know my primary offender is metabolic, it's the renal system. So metabolic acidosis, and my PCO2 is alkaline, so that means the respiratory system is kicking in to bring that pH up. So looking at my rules over here, I have an abnormal pH, and both of them are abnormal as well. So I have an abnormal pH with both bicarbonate and PCO2 being abnormal. Therefore, I have partially compensated metabolic acidosis. Example number 4. pH is 7.45, which is normal. PCO2 is 31, which is alkaline. And bicarbonate is 20, which is acidic. Now, over here, when the pH is normal, it tells us that's the only time that the pH is normal. That means that it's fully compensated. So, but now how do we determine whether we were alkaline or acidotic before? So if you look at this pH, it's really on the alkaline side of the pH. Knowing that the pH goes from 7.35 to 7.45, the 7.45 is more on the alkaline side of the normal. And then we look at, again, the PCO2, 31 alkaline, and bicarbonate acid. So in this case, because these two match, although the pH is normal, but it's more towards the alkaline side, so we have a respiratory alkalosis, and because the bicarbonate is abnormal as well, it is fully compensated. So basically, if you look at this back over here, the pH is normal, the PCO2 is alkaline, and the bicarbonate is over here. So those two have balanced each other out to help the system get back into normal range. And then our last example over here, the pH is 7.12, so it's acidotic. PCO2 is 41, which is normal. And then bicarbonate is 18, which is also acidotic. So now we know we have determined our pH, which is acidotic. Bicarbonate is acidotic, so we know we have a metabolic acidosis. And the PCO2 is normal, so the respiratory system has done nothing to compensate. So by our rules over here, pH is abnormal, opposite system has not responded, means it's an uncompensated metabolic acidosis. I highly encourage you to look at more examples, either in one of your books, textbooks, workbooks, online, to really apply this information. If you know the basics of how this applies to breaking down the carbonic acid and memorize these numbers as well as these steps, you really should be able to interpret any arterial blood gas that is maybe on a quiz or that you want to practice with. I am also going to have another video that explains the different causes and reasons and nursing interventions for the different arterial blood gas abnormalities and abnormalities in pH and what we can do to resolve those. Please leave any comments down below. I appreciate those. And also let me know if there are any other topics you would like me to review. And for now, thank you very much for watching Nursing School Explained.